pKa here is 25, and it could be removed with very strong bases such as sodium amide. And once you produce the anion here, that can be used as a nucleophile in a similar way that we use Grignard, and we make, again, new carbon-carbon bonds. So let's plan a molecule that has, we're going to be using the two reactions together. Now we have, let's say my reaction is the following. Let me just line structures. One, two, three, four. Not. Okay, so now we see, we're gonna see a couple ways of disconnecting that. So first, I'm gonna try to make this bond. So I'm going to, using the disconnection approach, how do I make that bond? And from what? What reagent can I use to make this? They might have the possible nucleophilic attack. So let's go and do first what I need to do on the two fragments. When I disconnect that, this, in a similar way to what we did before to the Grignard, this fragment on the right that has the OH can come actually from an aldehyde. And looking at the number of carbons here, 1, 2, 3, and 4, we need an aldehyde, and thinking backwards, right? That will be an aldehyde that will have 4 carbons. Right, that could be one fragment. The other, we need a nucleophile. What the nucleophile is going to come from the terminal alkyne. So after we treat a terminal alkyne with sodium amide, you're going to form the following anion. And that can act as a nucleophile. Say, for example, that I have ethyl bromide. That can do a nucleophilic attack. This is an SN2 reaction, and you will form the following. So you're adding carbons to the chain. Notice here that I have added this fragment, which is here, that come from the ethyl. So that is the type of reaction that we're going to be doing. So again, another reaction other than Grignard that we can use to make new carbon-carbon bonds. But we're using again an aldehyde, and we have determined that this fragment that contained the oxygen had 4 carbons. Now this needs to come from a terminal alkyne. So it will be 1, 2, 3, my alkyne. That will be a metal, that alkyne. And that, how do we do that nucleophilic attack? Well, I need to treat this, to make this an ion, that will be the nucleophile attacking over that carbonyl. How do I make that an ion? So we're going to be using that reaction that we did before. How is that? So we have a terminal alkyne, and this time I'm going to draw just the hydrogen, which with the sodium amide, and here that works, a pKa of this is 38. Well, actually that pKa obviously refers to ammonia. That's that conjugate base. So that's a pKa, and because it's larger than this pKa, it works. It will form the anion that we have here. So we start with a terminal alkyne, we make it react with sodium amide, and then we will react it with the aldehyde. We will have the nucleophilic attack. So again, we did a similar approach. We disconnected that. We determined the fragments here. This come from this aldehyde having 4 carbons, and we determined what is the nucleophile. So similar to the analysis that we did for the Grignard, we're making new carbon-carbon bonds.